Okay, hi everyone. Welcome back. We're going to do a few notes today, and then remember we have homework due tonight. So if you haven't already, make sure you're getting that submitted. You probably already have it done from last week, but if you haven't already, make sure you get that due. It's due tonight. You will probably get a small assignment today. I think it's 4 or 5 problems today that's due later this week. I think I have it set for Thursday this week, which is based on this stuff. So don't feel like it's going to be something radically new. It's going to it's a continuation. It's got some different looking problems. So that's what we're going to look at today. I'm going to go through a couple examples here with you where we'll go through kind of reviewing the stuff that we've done on the homework today. So maybe you have a couple questions. We can do a couple of those. Maybe at the very, very end, if you have a certain question you'd like to go over, I can pull one up for you and I'll draw it up. And then I'll do some of the new stuff today as well. We have 2 new properties, as you can see from my iPad screen. If you guys can see that on the marker board, I think you guys can. We have theorems, 3.4 and 3.5, so we're going to look at those today. Again, those are converse theorems. So we talked about the word converse yesterday. It was taking... Whoa, sorry. Sorry, got a lot of text messages coming through there. All right, let's turn off the Wi-Fi. All right. Again, converse is a conditional statement. It's an if-then statement where all they did is they switched the 2 parts around, the hypothesis conclusion. So that's what we're going to look at today. So we'll look at those last 2. Is there any questions before I begin? Maybe I'll start there from the homework or anything like that. Let's start there. If you have a problem you'd like to see or that you're not sure of, that you want to just know if you're doing it right, let's fire those out there right now, because I don't want to waste time. I want to get to those first because that's your first priority today. So does anyone have a question on a certain problem? I can pull it up. Any questions at all? Silence. Maybe it's too early to ask questions. Maybe I'll ask that question later. Maybe I'll get a little more confidence as the morning progresses here. All right. So let's just get started with some notes. Again, if you have a question, maybe you need to just look at the homework problems a few times. I'll make sure that I'll go over those problems that maybe at the end of class. Maybe I'll get a little more confidence here. But I want to give you a little bit of time today. Again, you will get a new assignment today that will be due later this week. It's based on the same material, so don't feel like it's going to be brand new. Just pick a few more problems. So, all right, let's jump right in. So these are going to be kind of a review of some of the problems we've previously done. So this is like the stuff you're doing now in the homework. So pretty traditional looking problems. What we have to do is we have to find the value of the missing variable. So we have to find x or y or whatever letters are in the problem. So in my particular case, we have a bunch of x's here. So we're going to be trying to find x's. So when we look at this problem, remember the properties you need to know. Alternate interior, alternate exterior. We have corresponding angles. Consecutive, which is same side interior or same side exterior. And then obviously vertical. And sometimes you got to mix them together so you can actually solve. Remember, you want to solve one letter at a time. And don't assume anything. Don't assume any angle is 90 or anything like that, unless they have it clearly marked. I'll show you an example of that later. All right. So in this problem, there's a couple different ways I could approach this one. My thinking here is probably what most people would agree is probably do vertical angles. So let me draw what I'm talking about here. The 3x here could go vertical. Does a little funnel system up to here. Again, vertical angles are equal, right? They can go through the little funnel system. They're 2 lines crossing, so you can transfer the 3x over. And then now that we're looking at here is we have 2 angles. They're inside the parallel lines. I'm going to draw little parallel symbols here. These are parallel lines. You can kind of see that. And now we have 2 angles that are on the inside, and they're on the same side of the transversal. So they're inside and the same side. So consecutive interior or same side interior, if you will. What do we know about these 2 angles? What's the property that allows me to work with these 2? What do we know about same side interior? I'm going to wait for somebody to volunteer an answer. What do we know?
Can you say it one more time? They have to equal 180 degrees.
Yeah, good, great. All right, so yeah, so they have to add up to be 180, right? So I'm going to just set those two up and, add them together and set it equal to 180. So yeah, nice. So 180. So they have to add, right? That's the same side interior. Like if that's the only weird property we have is that the two same side interiors have to add up to be 180. Everything else is usually equal, like alternate interior, alternate exterior, vertical, corresponding. All those angles are equal, but this is the rare one where they have to add up to be 180. So good spot on that one. So we're going to get 5x plus 45 is equal to 180. If I subtract the 45 across to get 135, because again, you want to get the variable by itself, right, so you can solve. So I subtracted the 45 across, and then I want to divide by 5, right? Divide by 5, divide by 5. If I do that correctly, let's see, I'm going to get 2 and 27 degrees. Is that right? 135 divided by 5? 27. So there you go. Now, on this particular problem, there's only one letter. So one variable. I found x. I'm done. There's nothing else I need to do. Alright, questions on the first one. Maybe how I set it up. Maybe you missed a step there. You didn't understand how I did something. Silence. Silence. Okay, alright. I'm going to take silence as it's too early for that question. Let's just move on and maybe you'll get some questions later. Okay, now we're getting into the new stuff. Okay, so I'll come back to a problem later about from the last section, the stuff that we were just doing in the homework that's due tonight, right? But this problem in particular, this picture, is something I want you to know. This is a part of the new stuff today. You're going to get pictures that are a little more complicated, right? There's more things going on than just two parallel lines and a transversal. This one has a lot of parallel lines. In fact, L and M are both parallel. You can see that. In fact, I'll put the little pink arrow here. These are parallel to each other. You can see that. And then the other two are parallel. So I'll put a little marker there. I'll put it maybe in yellow here. So those are parallel to each other. All right, so what we're going to be doing here is we're going to be finding the value of each of these numbers. So I'm going to give you guys a little bit of time here to kind of work together as a class. I'm going to give you one of these angles up here. I'm just going to tell you one number. And what we're going to do is we're going to bounce that number around the picture and state what's equal to it. Okay? And hopefully this will make sense to you as we get going here. So the number I'm going to give you angle number 1. The measure of angle number 1. I'm going to tell you that angle number 1 is 110 degrees. It's 110. So here's what I'd like you guys to do. So in class as a whole, I'd like you guys to discuss this angle 110. It goes on the picture here, and I want you to figure out what angles are also 110 on this picture. Numbers, like is it number, is it angle number 6? Is it number 7? You have to tell me which numbers. Okay, so discuss it. I'll give you 3 or 4 minutes. When Miss Scott, if they feel like they're ready to kind of tell me some answers, it doesn't have to be just one person. It can be the whole group as a collective unit talking it over. I'll give you a couple minutes here, and just let me know when they're ready.
All right, you guys can, if you want to raise your hands, if you want to discuss it, go ahead. 3, 6, 10. 2, 6, 10. Does anybody agree? Just 2 people? Everybody agree? Can you show me your hand? Okay, does anybody disagree? Does anybody see another angle? 6? Yep. Okay, can anybody tell me why?
No.
Why? Anybody else want to take a guess at it? Go ahead. 9. Okay. Why do you think 9? Okay, I'll accept that. Anybody else? So I'm hearing is we got 3, 6, 10, and I think 9. All right.
Okay, so 3, 6, 9, and 10. All right, I'm going to write those down. 3, 6, 9, and 10. All right, so these you're all saying that are 110 degrees. Okay. One of them is wrong. One out of those numbers. 3, 6, 9, or 10. One of them is wrong. So now, discuss that. Figure out which one you have wrong.
Say 9. Why do you say 9? It's acute. So how does that compare to angle 1 that he gave you? Obtuse. Okay.
Okay. Is that a final consensus? We think 9 is wrong?
Yep.
All right, good choice. All right, so let's cross that one out. All right, and that was super good reasoning, by the way. That it's it looks acute versus obtuse. Good choice. All right, so let's discuss why you guys are correct on these 3, 6, 9, and 10. Or sorry, 3, 6, and 10, I should say. All right, I heard 3 first. Why 3? What are those angles?
They say corresponding angles.
Yeah, they're corresponding. One's inside 2 parallel lines, one's outside the 2 parallel lines, and they're on the same side of the transversal. The transversal would be L in that case, and the 2 parallel lines would be J and K. So yeah, so those are corresponding. One's inside, one's outside, same side of the transversal, physically not touching. So good. Now, why 6 from there?
They say funneling and vertical angles.
Yes, exactly right. Funneling and vertical. Vertical is the technical term. I like to use the word funnel, so I agree, completely agree with that. And then why 10?
Corresponding.
Yeah, I heard that. Corresponding. Yeah, it corresponds down. Because the parallel lines in that case would be L and M, and K would be the transversal, so you have one inside, one outside. They're on the same side of the transversal, not physically touching. But again, I like the reasoning that you guys said earlier too, is like, you can tell up here by looking at the picture that you have obtuse angles versus acute. That's a really smart way to think about it. So if I kind of look up here, the other obtuse angles would be this one, and this one, right? The ones that look obtuse, and that little guy, the ones that are not marked. All those angles are also 110 because of vertical, because of corresponding, alternate interior, however you want to think of it. Those are the other reasons why. So yeah, that was super good reasoning. Today, one of your homework problems, is going to look very similar to this, where I'm going to give you an angle. I'm going to give you one of the numbers up here, and you have to find the other angles that are equal to it, all the other numbers. So be careful of that. So it'll be, you have multiple parallel lines, you have to kind of bounce the number around the picture, and you just have to tell me which angles equal that one. So, does everyone understand one of the homework problems you're going to have today? Okay, I'm going with it. Alright, so that's going to be one of them. Alright, now let's get to the other types of problems. So now, the other looking problems you're going to have, the other types, will be a shape. You know, they're not going to be that traditional parallel lines, transversal cutting through them. They're going to actually be shapes, and you have to apply the same properties. So on this particular picture, we have a bunch of parallel lines. So I'll draw the little like pink and yellow arrows here. So these are parallel. Again, a double arrow just means that they're parallel. I'm just trying to differentiate. All right, so on this picture, you have a bunch of parallel lines. You can extend these walls further if you want. So I know some people like to do that. They like to take the picture and extend the walls further to make it look kind of like the last picture I just showed you. You're always allowed to do that, because maybe that's easier for you to see. Maybe you like to see it like that so you can see where the parallel lines are going, where the transversals are. Doesn't really matter. But on this particular picture, so if I gave you one of the numbers, let's say I gave you angle number 1, and this was, 80 degrees. It can hopscotch around the picture, right? It can go to different locations. It can go to number 2. It can hopscotch to 2. Angle 1 and 2 are the exact same angle. I want to know why. I want to know what property allows me to have 1 and 2 being both 80.
Can you hear them?
I couldn't. No, sorry.
I say alternate interior.
Yeah, alternate interior. So that angle number 1 and 2 are alternate interior. They hopscotched, right? They're on the opposite sides of the transversal, or alternate sides. They're both inside the two parallel lines, so it's alternate interior. They're equal. Good, nice. That was, I think, our first theorem we learned, theorem 3.1. So good. Now, I can hop the 80 to the number 3. It's a pretty far jump. Why? I think I heard it.
Corresponding.
Yeah, thanks. Yeah, corresponding. And so that can hop. And that was a postulate. That was our first postulate, postulate 3.1. Right? Postulates, again, are a property of mathematics that we assume are true. We don't prove them. It's like a fundamental in mathematics. It's a basis of knowledge we have to use. So nice. So being able to see that's really good, that you guys are starting to spot those properties, even though the picture didn't look like the last ones I did, right? It didn't just look like parallel lines. Sometimes just extending the walls, you can see that a little bit better. So that was really good, really nice spots. Again, if you're struggling on this stuff, maybe, because I know I received a couple emails yesterday throughout the day, just let me know. Ask some questions today, especially at the very end if we're going to get back to the homework. Maybe you want to see a certain problem, you want to know how to do it. That's a good time to ask today. You can go right up to the front computer with Miss Scott there, and you can ask a question. So, all right, same exact problem as before. So it's basically the same looking picture. I just didn't have the extra lines in there. So the lines can extend further. Extending these out. Okay, so on this particular picture, kind of transferring some numbers around. So giving you some numbers here. Whoa, apologies. All right, so let's give some numbers here. Let's go with angle 1 is 120 degrees. Kind of a larger number. Okay, so let's talk about it. Where can I bounce this 120 to?
Three.
You can go to 3. Okay, I heard that. Because of alternate interior. Okay, so that's 120. And what else? 2, right? 2, and that's what? Corresponding. So that's 120 there. Okay, so we bounce those numbers around. Now, how do I find 4? Because 4 doesn't look like 120. It doesn't look like the other ones. It doesn't look obtuse.
180.
Yeah. So what you're saying there is that these should make 180. However you want to think of it. I don't know how you're looking at that. Whatever pair you're looking at, they have to add up to be 180. So I'll go with angle 2 and 4. They're same side interior of the two parallel lines. The transversal is the line going from Z to X. So the 120 and angle number 4, I'll just call it X, should add up to be 180. So I'll just call this X for right now. And so you would have to figure out that this angle has to be 60, right? 60 plus 120 makes 180. So that's angle number 4. That's the measure of angle 4. All right, very nicely done. So that is not an easy problem. It's a good way to spot that. I like the fact that you guys kind of recognize the obtuse and acute angles from earlier. That does make this a little bit easier, that you can spot what angles are supposed to be equal, what angles look large, which angles look smaller. That's a good way to do it. So, all right, very nice. Now, there is a problem that we need to talk about. Now, this one looks like the ones we did yesterday, or the homework that's due tonight, right? I bring this one up for a reason. This problem in particular, why I bring it up, is because if you notice, it has a very specific 90-degree angle drawn there. It's that perpendicular symbol, right? The little box. That angle right here is 90 degrees. Right? It's a perfect 90. And we can use that, right? We can transfer that up using corresponding up to here, and we can set this one equal to 90. And then you can solve for x, whatever x is. It could be any positive, negative number, it could be a decimal, who knows. But that's a very specific angle, right? They told you explicitly what that angle is. Never assume that angles are 90s unless they tell you it like this, where they have a little box in the corner. So on this picture, every angle is 90. But I want you to recognize the corresponding angle here. That you can transfer it, from the bottom up, as long as it's on the other side of the, that parallel line. One's interior, one's exterior, same side of the transversal. this doesn't look like much, but this property, other than the 90, ignore the 90 right now, this property, this corresponding angle, is something I'm going to use on the next picture. And this is the one that I promised you yesterday that I was going to spend the most time on. It's this next example coming up. You have one of these on the homework. I thought you were going to have two, but you have one of these for sure. I just want you to see this. This is the problem I gave you yesterday. It's the exact problem. I just never solved it. I said this is the one we're going to look at. This is just, it's not a difficult problem. It's just different. And I want you to see how to solve this thing. The goal is to find x, right? To find that missing value. To do this problem, you have to recognize corresponding. Now, right now, I know that, x is not 50. You can see it. X is a very small angle compared to 50. They're not the same number. How we actually are supposed to attempt this problem, and this is kind of a rare thing, we have to use that parallel postulate that we talked about yesterday. Parallel postulate is that property from I think it was 200 AD or 300 AD from Euler, or from Euclid, I should say, the mathematician, where you have a line and you have a point that is not on it. You can draw a parallel line through this dot. So I'm going to add in a third line to this problem. So here's my third line. Now, by adding that extra line on this picture, it split the 72 into two different angles. So this 72 is no longer that small angle. It has now been broken up. So I'm going to draw over top of that. So I'm going to fill this in. This is no longer 72. The entire angle is 72. This entire thing is 72, but not that little wedge piece below it when I drew my extra line. Okay? So what we have to do is transfer numbers around using corresponding. This 50 can hopscotch to right here. It can be this tiny angle right there. The little piece of that angle. So that's 50 because it's corresponding. They're on the same side of the transversal. One's inside, one's outside the two parallel lines. The parallel line is that that pinkish red line, and the blue line at the bottom. Now, what is this other angle? What is the other angle that is supposed to be right here?
Uh, 22.
22, yes. Now, how do we know that? You are correct. Say it? I couldn't hear that.
Here, they say because it has to add up to 72.
Yeah, exactly right. They had to add up to be 72. The entire angle is 72 there. So having that 50 down below automatically forced the top angle to be 22. So you're absolutely right. Now, that 22 will hopscotch up to here using corresponding again. Because now the red line and the top line are parallel, so I'm on the same side of the transversal, and now I'm going, on the one's inside, one's outside. So that 22 will hop up here, and this is 22 degrees. That's how you attempt this problem. That's how you find x. X is a 22. Now, it's not like overly difficult. It's very different than any other problem we've done because you had to add an extra line on the picture that wasn't there, and you had to know what to do with it. We had to break up the 72 into the two parts we talked about, but it really required that you know your properties really strong. Like if you didn't know corresponding, this would have been an impossible task. You wouldn't have been able to know that you could transfer the 50 and then break up the 72 and then go from there. So this is just one I want you to know how to do. You have one of these on the homework. I will provide you a new number, and you have to go find the rest of the variables. So, all right, questions on this one though? Crickets. Okay, so let's look at our properties. So now what I'm going to do is I'm going to review the two properties we had yesterday in case you were gone or absent. I think everyone was here yesterday. So, these are from yesterday. These are the same pictures. There we go. Now we're at the properties. Okay, so here's the postulate we talked about yesterday. This was the first postulate. It's technically the second one in this unit we're in. We're in Unit 4, which is Chapter 3 of your textbook, but this is the second postulate we've had, so it's entitled 3.2 because it's in Chapter 3, second postulate we're learning. It is the converse of the corresponding angle postulate. We talked about this one yesterday. A converse is where you take a mathematical statement and you flip it around. So I think the example I used yesterday, I said, if it is snowing, then I'll wear a jacket. Well, a converse of that statement would be, if I'm wearing a jacket, then it is snowing, right? I switched the jacket and snowing parts around. Well, that's what this postulate did. This postulate was actually 3.1's postulate. They just switched the words around. 3.1, if you don't remember, was the corresponding angle postulate. It said, if two parallel lines are cut with a transversal, then the corresponding angles are equal. Well, this one flipped the words around. They're saying that the corresponding angles are equal, then you have parallel lines. So it's flipping the two words. But again, this idea is what I just used in that last problem, that when you have two lines and you have a transversal, if these angles were to equal, these two angles, these corresponding, it forces the lines to be parallel. And again, this is a postulate. We don't prove it. We accept it as truth. Now, the only evidence we have for this one is because we can refer back to a protractor. Right? You put a little protractor, you measure your angles, and it forces them to be parallel. There's no other option. So, okay, so that was a postulate. That's the one we had yesterday. Does anyone need that one today? Does anyone still need to write that one down? I think we had it yesterday, though. Okay, all right, let's move on to the next one. Again, we had that one yesterday. And again, if you are missing that one, you can go onto my website and get the slides. So again, mrward.org, go check up the main site. You can download that from the videos and stuff. Or the pictures. I had the pictures of them. All right, so postulate 3.3. This is the second one we did yesterday. So again, we've had this one yesterday. It was called the parallel postulate. This one I referred to earlier. This is Euclid's postulate from 300 AD. Given a line and a point not on it. So here's my line. Here's a point not on it. There exists one and only one line that could pass through that point. And be perfectly parallel to the bottom line. There's only one. Now again, the reason why this works, again, we're not proving it, but the reason why it works, you draw a transversal, you tilt this line up or down in such a way that it makes the corresponding angles match, and it forces the lines to be parallel. There's only one option you have to do there. Possibly when I'm back over, next week sometime when I come back, we're going to look at drawing this, like construction-wise, actually using like protractors and compasses and whatnot, and actually physically drawing this on paper. That's something I want you to be able to experience. It. You can actually make this drawing in such a way that you can draw a perfectly parallel line using a piece of string. I'll show you that for next week when we do constructions, because we've done a few constructions up to now, but now we have to talk about perpendicular and parallel. So parallel will be the first one we're going to do. All right. Does anyone need this? This is the one we had yesterday.
Doesn't look like it.
Okay. All right. New properties. These are my last two slides of the day. So once we're done with these slides, you're done. Remember, we have homework due tonight. So make sure if you have not submitted the Google form tonight, you're doing that. And then we will have a new assignment. I think it went live about 10 minutes ago. That one's due this Thursday, so you're going to have a lot of time tomorrow in class to work on that. So I want to give you time and ask questions. So tomorrow might be just a day where I might just turn on the Zoom and just let you guys kind of work. And if you have questions, you can go up to the front of the class and ask questions right on camera. So I do want you to have that time where you can ask me and communicate. And you can talk to Miss Scott. She's taken plenty of my math classes before, so she's probably well aware of how to do some of this stuff too. So, all right. Yeah, let's jump in. Let's talk about our new property here. So these are theorems. We do have to talk about why these work. They're pretty obvious. They're going to use those two postulates we just went over, but they're called the alternate interior angle converse. This is the first one, 3.4. Now again, these numbers in your textbook, they're different theorem numbers. I'm going a little bit out of order. I'm trying to make these as easy as possible to remember. So this is the converse of the first theorem we learned. So 3.4 is the alternate interior angle converse. So if two lines in a plane are cut with a transversal so that their alternate interior angles are equal, then the lines have to be parallel. So let you write that down. As you're doing that, I'm going to draw a picture of what they're talking about here. So 2 lines in a plane, in a flat surface, right? And they're cut with a transversal. Here's my transversal, I'll call that T. And again, these lines are parallel. That's what we're trying to show. We're trying to prove this. That's what we're trying to prove, okay? But they're giving us the alternate interior angles are equal, so let me mark those. This angle and that angle are the same. Alright, I'll let you write it down. Miss Scott, when they're ready, just let me know and I'll walk through the proof here.
Perfect. Does anybody need more time? Alright, they're good to go.
Okay, alright, here we go. So, let's talk about it. So alternate interiors are equal. They give me that. That was the given, right? Well, I'm going to do a little bit of vertical angle. I'm going to transfer. I don't care which one I go to. I'm going to just transfer one of these angles. So I'm going to go vertical. Let's use a yellow color here. Let's go vertical up to here. And this angle is the same, right? Vertical angles are equal, the little funnel system. So I transfer the angle up. Now that I've transferred that up, you can see on this particular picture that these 2 angles are now matching. Those 2 angles. What are those angles called now? Now that I've went vertical, what are those 2 that I've marked in purple?
Corresponding.
Yeah. Now what I've just done is I've shown that the corresponding angles are equal, right? It's corresponding angles. Those matched. And so the postulate we just had a little bit ago, that was postulate 3.2, right? 3.2's postulate said if the corresponding angles are equal, then the lines are parallel. So that's actually the proof right there. You do vertical, and then it forces the corresponding to be matching, and that forces it to be parallel using a postulate. So, very nice. Good spot on that. Okay, and the last theorem here. Last theorem. So that was it. That was the whole proof. There's not much to it. Alright, last theorem. This is my last slide of the day, I promise you. And then I'll just give you time where you can kind of work. We have about 7-8 minutes here. So theorem 3.5, consecutive interior. Consecutive interior. So again, Miss Scott, when they're ready, just let me know.
Absolutely. Does anybody need more time? Alright, they're ready.
Alright, perfect. So, again, this one's short and sweet and to the point, just like the last one. So we have 2 lines cut with a transversal. And again, we're trying to show that these lines are parallel. We're not assuming that they are. and we have a transversal cutting through them. There we go. Alright, so there's my line cutting through, and we're given that the consecutive interior, so that would be like this angle and this angle. Now we know consecutive are not equal, we know that, right? But they're saying that they're supplementary, right? So x plus y has to equal 180 when you add them together. That's what supplementary means, right? Supplementary. Alright. What I need to do is I need to show that these lines are parallel. You know, that this forces the lines to be parallel. Okay, so here's how I do it. This is going to be kind of an interesting way to just show it. Okay, so, all right, this is the best way I can do this. I'm gonna create a new letter here. Okay, so I'm gonna create a new letter just so you can see this. I'm gonna call this W down here. W is a new letter. I'm just throwing it down there. Now that this green line down here, this was, I'm gonna mark this in black. This was a straight line. So what should W and Y add up to be?
80.
Say it?
180.
180. Okay, so yeah, so you can see that, right? Because they're kind of put side by side. They're called adjacent angles. They make a straight line. A straight angle is 180, right? So it goes with the definition. So now, if you notice, both of these equations have the same 180 in them, right? They both have 180 in their numbers. So I can actually substitute using a little substitution rule these in for each other, right? And replace the 180 in the line up above, right? Replace the 180 with this mess. Just replace it there because 180 means W plus Y. They're the same thing. And now when you look at this, you can see that on both sides of the equation, I have the letter Y. Well, this is an equation, right? There's an equal sign. I can do the same operation of both sides. It's called balancing equations, right? I can add, subtract, multiply, divide by anything I want. As long as I do it to both sides of an equation, it's still balanced. Well, I'm going to subtract the letter Y from both sides, like angle Y, whatever that number is, whatever the digit is. I'm going to subtract it from both sides. What would happen if I subtracted Y's from both the left and the right side? What would be left?
X equals W.
Yeah, you get X equals W, right? And what you just wrote there is basically proving my point. I just showed, by just doing a little simple algebra here, that X and W are the same angle, right? Let me go mark this on the picture. X and W happen to match. They are exactly equal to each other, right? We just showed that. This is a part of the proof over here, right? Well, the last theorem we just did, 3.4, just talked about this. If the alternate interior angles are equal, then the lines are parallel. And that's what we're showing here. These are alternate interiors. We just show that they're equal, so this forces the lines to be parallel. So that's the whole proof. So it's doing a little bit of algebra. So, all right. You have the rest of class here, not a long time, sorry, to kind of work on your assignment. You have an assignment due tonight, so if you've not turned in that Google form from last Friday, make sure you're doing that. Type in your answers. You have a new assignment, went live today. I'm going to give you a lot of time to work on it tomorrow. It's due, I think, Thursday this week, and I can change the due date, but it's due Thursday for right now. Again, tomorrow I'll just kind of leave the camera kind of on for a majority of the class. I might talk about something right away in the beginning, but tomorrow might be kind of a little work day for you, so you can work on some homework. So, all right, that's all I have. Miss Scott, is there anything that you can think of that I'm maybe forgetting at all for class?
I don't think so.
Okay, so okay. So thanks for paying attention, guys, and taking notes today. Remember, you have homework due, so get that done. Good luck to the basketball team tonight. So good luck, Miss Gouge, tonight. You guys got West Hancock tonight, so I wish I could be there. So, but yeah, so take care of each other, and I'll see you guys later.